So good morning to all of you guys. Our next lecture is that we have to talk about that. Our next topic is that in your phone there is a, we are talking about that our exercise. So there is a, we are continuing our 10 exercises over. So now see, polythene piece rubber with the wool is found to have negative charge. So see how much charge is that. Here negative charge q, it is what, see here negative charge, it is what, how much is that, q is equal to 3 into 10 to the power of minus 7. Estimate the number of electron transfer. So see here again we have to talk about that the our we are talk about our uh, quantizations of electron. Okay, quantizations of electron. So see q it is equals to, we are discussing about that the q it is equals to Ne. So in this q it is equals to Ne, but here we have a negative charge value. It is what, there is a negative charge value. It is equals to 3 into 10 to the power of minus 7. So number of transfer, how much is that? So we know about that the charge of electron. The charge of electron is what, see there is a value of electron it is equals to what, 1.6 into 10 to the power of minus 19. So see this one 1.6 into 10 to the power of minus 19. So it is what we have to do here. Again there is a charge q it is equals to minus, and also there is a q it is equals to minus Ne. Okay, but see now again what will happen, there is a value of q negative charge. Negative means what will happen, there is a negative values is that. So 3 into 10 to the power of minus 7 is that, and divide by 1.6 into 10 to the power of minus 19. So if we are doing that the multiplication divide of these things, then we are get the value of n, the total number of electron transfer from which to which, means from here to there. Okay, so it will be transformed from charges from which one, it is a the, here we are getting that the n it is equals to n into 2 into 10 to the power of 12, because here instead of there is a written one mistake is that, see there is a, here we are taken as 3 into 10 to the power of minus 7, and here it is written as 3.2. So it is a one of the mistakes. So that's why we are getting that the answer it is equals to 2 into 10 to the power of 12. Okay, so our next slide is that. So see our next sum is that, see, and now again in this sum we are talking about the polythene piece. First one, it is there transfer from mass from wool to polythene. We are talk about that the in the process of mass will also transform. So a number of electron, see here number of electron transfer from wool to polythene. Hence what will happen, wool's loss from mass of n number. So here now a electron it is transfer, electron it is what will happen, it is going to from one position to another position. So what will happen, there is a electron have on mass. So how much mass is that? So suppose there is a number of electron, it is one from positions to another, so it have a something mass is that. So that's why we are multiplying with the mass n into number of mass, n into value of mass. So here what will be there, here value of n it is equals to, we are find out the value of n it is equals to what, 2 into 10 to the power of 12, and here the mass of electron it is what, 9.1. see mass of electron it is equals to what, 9.1 into 10 to the power of minus 31 kg. So we are getting that the final answer is that what, 1.82 into 10 to the power of minus 18 kilogram. So whenever we are multiplying with this, then we are getting that the your finalization answer is that 1.82 into 10 to the power of minus 80 kilogram. Okay, so now again we are our next slide. So see, it is a cancel example for this year, but unfortunately for you it is a, you are luckily to still your total syllabus you have to cover. So see now we are again, there is a two charges that copper sphere A and B is that have their center separated by distance with this centimeter is that, with this our centimeter it is what, here 50 centimeter. What is the mutual force of electrostatic repulsion? So see there is a repulsive force is that. So repulsive means what is the mutual force of electrostatic repulsion if charge on each is 6.5 into 10 to the power of minus 7 coulomb. So see there is a 6.5 into 10 to the power of, there is a two charge. So see suppose one of the this bob and another and this bob. So both A and B both have, what will happen, their centers separated by distance. So they are separated by distance of, suppose it will be distance between this, suppose this one bob and this one bob, separated by distance, it is our 50 centimeter. Okay, so what is the mutual force of electrostatic repulsion? So here says the repulsion force, it means both are same charge, both are same charge. So it means what, here no positive and no negative charges are there, only positive charge, both are positive charge. So here what will happen, there is a repulsive force will be applied, and the radii of A and B are negligible compared to the distance. So suppose here what will happen, there is a distance, so center of this bob, center of this bob and center of this bob, but we are considering this portion. Okay, we are just considering negligible portion. Why? Because of this portion we are considering it is a negligible, because of that we are taking as our sphere, it is very small. Sphere, it is what, it is a very small. So what will happen, require the Colombian force is that F, it is equals to, again we are talking about the F, it is equals to K QA QB upon R square. So distance, how much is that distance, it is equals to, we are talking about the distance Q, it is equals to what, see here, or distance, it is equals to 50 centimeter. So 50 centimeter we have to convert in meter, so meter we have to convert. So what will happen, F, it is equals to K QA QB upon R square. Okay, so what will happen, there is a value of our K, value of K, it is equals to what, K we know about the value of K it is equals to 9 into 10 to the power of 9 into 10 to the power of 9. So what we can say, it is a value of K, it is equals to K, it is equals to 9 into 10 to the power of 9. Value of Q, it is equals to what, Q, it is equals to Q and QB, it is equals to both are same. So we can write 6.5 into 10 to the power of minus 7 coulomb. Radii of A and B are negligible compared to the distance. And so here we are talking about that the distance between two charges is that what, it is equals to 0.5 square. So here we are multiplying all these things, 6.5 into 10 to the power of 6.5, 8 to 10 to the power of minus 7 plus minus 1, it means 10 to the power of minus 14 is that in minus plus 10 to the power of 9. So it will be cancelled to each other, and then final answer we are getting, it is what, CF, it is equals to 1.5 to 1 into 10 to the power of minus 2 Newton repulsive force. Because why, because of it is our like charge, it is our like charge. Okay, so our next slides is that, again, the what is the force repulsion if each sphere is charged double and the above amount and the distance between them is half. So what will happen, the force here, the force is that, okay, force of repulsion, each if each sphere is charged double and above amount. So see here, first of all, the Coulombian force, it is equals to what, the Coulombian force F, it is equals to, we can say F, it is equals to K Q A Q B upon R square. But see here what we are saying, there is a charge is double. Okay, charge is double. So instead of QA we can say QA, it is equals to 2 times QA. Okay, instead of 2 QA we can say it is a 2 times QA. Instead of QB we can written as 2 times of QB. Here downside what will be there, there is a there is a distance is the distance between them is, it is a half. So here what will be there, here distance is half. So first of all we are written as R square. Okay, afterwards what we are saying, there is a R square by 2. So what will happen, there is a, so here there is a 2 into 2, it means 4, and downside it is a R square, but there is a 2 is that, so 2 square it is equals to 4, but it is what, it is a denominator. Okay, is 2, it is denominator, so it is a 4. So 4 it is going to upside, so we can say 16k, 4, because upside it is also 2 2s are 4, so 2 2s are 4, and downside it is also 4. So downside, it means denominator, so it is going to where, it is going to this, going to upside. So what will happen, there is a 4 multiply 4, it will be 16k QA QB upon R square. So F dash, it is equals to what, how force it is equals to, we are getting F, it is equals to what, 16F. And the resultant force, when we are talking about the what, see, When we are talking about that the force is how much, force it is equals to 1.5 into 10 to the 1.5 to into 10 to the power of minus 2. So here we have to just multiply with this 16k. So repulsive force, it is how much, 0.2434 newton. How much is that? It is at 0.2434 newton. So see, suppose the sphere A and B exist. Exercise 12 1.12 have the identical size. A third sphere of same size but unchanged in the brought in contact with the first, then brought in the contact with second, and then finally removed from the both. And what is the new force repulsion between A? So suppose, see what will happen. There is a first one, it is my QA. Okay, this one it is a first sphere. It is contact with the second one. It haven't any charge. Okay, uncharged, so contact with the, suppose this one, so both are touch in contact. What will happen? It will be separately divided by charge 2a, qa by 2. Okay, qa by 2. So see here, what will be first one, it is a qa dash, it is equals to qc. So what will happen? There is a qa plus c, it is 0. So divide by 2, it will be qa by 2. Afterwards, what will happen? The second one unchained contact with the first, then brought in contact with the second. So see here, our c is contact with the d. So our qc double dash, it is equals to what happen? qc plus qb divided by 2. But qc, it is equals to qc dash, it is equals to what? qa by 2. I written as here qa by 2 plus qb. But what will happen? There is a qa plus q 2 qb. So it will be equals to 3 qb by 4. Okay, so see here, what will happen? There is a final conclusion force between that the F and B, it is equals to qa dash. One qb dash is that, see here, what will happen? First charge, it is my qa. Second one, it is a nothing charge is that. So first one, it is what will happen? There is a q, what will happen? There is a divide by 2. So here here what will happen? It is a divide by 2 means what? See, there is a charge, it is going to separate, or on the time it will be gives the down divide by 2. So q2 q by 2. Also there is a q by 2 is that. So now afterwards, this c have another q by 2 is that. So it is going to contact with our b, this one b, and then again what will happen? It is going to touch with them, and then after what they are doing, they are separating again. So one have a half and one have a full. So what will happen? There is a 75% both have is that. So what will happen? There is a, they are adding, and then after divide by 2. So here what we are getting? 3q by 4. So here we are getting 3q by 4. Okay, so 3q by 4 is that. Now this one, first one, this sorry, this first my qa by 2, and this last one we have to talk about this qa by 2 plus q3q by 4. And on the time, what will happen? Our distance, it is distance, it is remains same. So how much force will be there? Okay, so see what will happen? qa, it is equals to qa by 2, it is equals to qa plus 2 qb by 2, or 2 qb by 4 is that. So what will happen? It is a 2 qb by 4 is that. So 3 q by 4 is that. So we can written as qa into 3 qb. But here what will happen? There is a q and qb both are same. So 3 by 3, it is gone outside. 3 by 8 k qa qb upon r square. But see what will happen? There is a k, this k qa qb upon r square is that. This k qa qb upon r square is that. See this one qa qb upon r square, k qa qb upon r square, it is our f. So we have to 3 by 8 into f, we have to multiply. So what will happen? 3 by 8 into 1.5, value of f, it is equals to what? 1.5 to 1 into 10 to the power of minus 12, because we are already done in example number 12. So we are getting that the 3.3 by 8 into 10 to the power of 3.3 by 8 into 1.5 to 1 into 10 to the power of minus 2. So we are getting that the final answer is that f, it is equals to 5.704 into 10 to the power of minus 3 Newton. How much is that? It is equals to f, it is equals to 5.704 into 10 to the power of minus 3 Newton. Okay, so this one, it is our answer. So of that, our force, when we are talking about that the, we are going to separate, and when we are going to divide by them, it is equals to, we are getting our final answer is that what? Our final answer, it is equals to our f, value of af into 3 by 8. So we are getting that the final answer, it is equals to our final answer, it is equals to our 3 by 8 into f, so 3 by 8 into 1.1 1.5 to 1 into 10 to the power of minus 2 is that, so we are getting that the final answer is that 5.704 into 10 to the power of minus 3. So you have to do with your calc and then you have to calculate your answer. So write down these examples, still we are studying. Okay, afterwards we are talking about it, the next example. So see, a figure shows the track of three charged particle in uniform electrostatic field. Give the sign of three charge which particle has the highest charge to mass ratio. So see here what will happen, there is a plus 1, 2 and 3 charges, that first, second and third. So first have y1 is that height is it have velocity is v and charge is q1. Then after v our velocity is again same but charge it is q2, and then after last one it is what v and charge is q3, but downside it is our negative charge, upside it is our positive charge. So see what will happen, there is an attraction means what will happen, there is an attractive force. So this one and 2 it is our negative charge, and third one it is our q2 q3 is negative plate, so it must be positive charge. So here all are three particles enter uniform electric field perpendicular with the same horizontal constant, okay, velocity, then vertically displacement undergoes by them while coming out electric field. So see here what will happen, there is a change the position, change the displacement. Why the change the displacement, because it have velocity it is same, whenever it will enter in the our electric field on that time velocity it is same, but afterwards what will happen, afterwards it will be a our dt is equals to what v0 t plus afterwards it is positions will be changed, displacement undergo while the coming out electric field. So here what will happen, dt is equals to v0 t plus 1 half at square, but here v0 instead starting velocity we are talking about it, so it is 0, so v it is equals to what 1 by l by t, and fe it is equals to our ma. So force of here we have to talk about it, the second one is that v0 t plus 1 half a t square. So here value of a it is equals to what, a it is equals to our fe by m, okay, according to Newton's second law. And t square it is equals to what, so whenever we are talking about the velocity v it is equals to displacement upon time. So displacement upon time is that, so see here what will happen, there is a displacement upon time. So here what we can written as this v it is equals to l by t, l it is my distance and t it is our time. So, but we require the value of t, so what we are doing, we are making as one as we are making as main of this equation, and then we are find out. So y it is equals to what, 1 by 2 v0 it is 0, so 1 by 2 fe, instead of fe what we can write, fe it is equals to qe. Why qe, because it is a in electric field what will happen, there is a charge into electric field, it will be gives the full value of force. So see here what will happen, there is a our for this one fe it is equals to qe. Now how here see the charge of q it is constant charge, here e electric field is constant, l it is also constant, and we are same for all these three charges. So what is the change, so change it is only the mass and our charges, value of charges. So q3 must have space maximum specific charge, which is the charge to mass ratio or charge per unit mass, because it is undergoes maximum vertical displacement shown in figure. So see here it is what will happen, there is a maximum who is going, our y3 it is going to maximum downside. So it have what will happen, it have very specific, q3 must have maximum specific charge, so specific charge is maximum. So what will happen, it have a specific, so that's why it will be a going to, because y it is directly proportional to q. See, y is proportional to directly proportional to q and inversely proportional to m. So suppose see here what will happen, if suppose here value of mass it is increased, then value displacement it is going to decrease. So charge it is what will happen, charge it is going to increase, then our displacement it is also going to increase. So we are talking about it, so what will happen, y is equals to y is proportional to q by m is that, okay. So q3 must have maximum specific charge, which is charge to mass ratio or charge per unit mass, because it is undergo maximum vertical displacement or as shown in figure, okay. Now again another example is that we had considered uniform electric field. E it is equals to 3 into 10 to the power of 3. So electric field, value of electric field they are given. Okay, value of electric field they are given. Okay, so see here, this one it is our value of electric field. Value of electric field it is what? See this one it is our electric field value 3 into 10 to the power of 3 I cap Newton Coulomb inverse. So I cap what is indicate? It will indicate it is a follow in x directions. Okay, the field through a square of 10 centimeter on the side whose plane is parallel to yz plane. So in given area we can find out what we have to find out. We have to find the what is the flux. So flux we have to find. So flux phi is equals to what? Flux phi is equals to E into dA. But here area it is not given. Area is not given. Value of L is given. Value of L it is equals to what? 10 centimeter. So 10 centimeter it means 0.1 meter square. Okay, so multiply with the L into L. So what we can say? L into L it is equals to square. Here see square is that, so we can return as L square. So our electric field our flux phi it is equals to what? Flux phi it is equals to phi 1 a1 cos theta 1, but a1 it is equals to what? Our L square E cos theta 0. Why? Because a1 and e1 both are parallel. So flux phi is equals to what? 3.1 into 10 to the point 1 into square into 3 into 10 to the power of 3. So we are finally get that the result flux phi it is equals to what? Phi it is equals to 30 Newton meter square upon Coulomb square. Okay, so this one it is our example number 13 1.15. Now we are talking about next example, not next example, only just change the our degree, make the plane is 60 degree. So again same flux phi 2 it is equals to what? Flux phi 2 it is equals to again this phi 2 it is equals to a2 cos theta 2, and a2 it is equals to again value of L2 e cos theta e cos 60, but value of L it is equals to zero point 0.1 square. Value of E it is equals to 3 into 10 to the power of 3, and cos theta is equals to what? 1 by 2. So we are getting that the final result of that it is equals to 15 Newton meter per Newton meter square upon Coulomb. Okay, so this one it is our answer is that. So we can say our Coulomb flux, what is the flux is that with the angle, particular angle. So our next topic is that what is the flux of the medium electric field exert or exercise on 1.55 cube of side 20 centimeter orient so that phase are parallel to coordinate plane. So see here as per statement coordinate axis are parallel to force phase given cube 2 length L it is 20 centimeter. Here outflux surface outflux out of the 6 phase of above cube 4 phase are parallel to electric field. Okay, so hence the no electric flux through the this 4 phase. So see this one 1 2 and 1 this one only 2 phases are there, they are allowed to the passes of our electric field. Which one? See this one, first one and second one. Okay, say first one and this first and this second only allowed to the flux is passing through the phase 1 and phase 2. Okay, but another one our another one this one and this one it is downside. This see this one downside, this one up backside also this it is also those four are not able to pass the flux because both are downside it is also parallel and also side of that our cube it is also parallel. So flux passing through the phase 1 it is equals to a1 e cos theta 1 phi ADA. Okay, so see here A it is what, here L square it is given, so L square E cos theta, but here theta between this 1 and 2 there is a how much difference are there angle, it is a 180 angle difference are there. Okay, 180 angle difference are there, so we can written as L square E cos 180, but here the cos 180 value of cos 180 this value of cos 180 cos 180 it is equals to minus 1, it is equals to minus 1. So we have to put that value of minus 1. So minus L square E divide into, see there is a force 5 2 on that time, what will happen, there is a 0 degree. Okay, so E2 is that what will happen, there is a is A2 E cos theta 2 into L square E cos 0 theta, instead of 0 theta we can return as 0, but cos 0 it is value of 1, cos 0 value is 1. So here cos 0 is 1, so we can say L square into A. But now flux phi is equals to what, phi 1 plus total flux passing up through the cube, so flux phi 1 and plus phi 2 it is equals to minus L square E plus L square E. So total flux will be 0 of the this outward flux from this cube. Okay, outward flux is total flux will be 0 from out will be coming from that the our cube. Okay, so this one it is our first question answer is that. Now afterwards we are talking about that the our another question. So careful of electric field at the surface on black box indicate that the net outward flux. So see outward flux of surface is of the box is 8.3 into 10 to the power of 3 Newton meter square coulomb. So what is the net charge? So here what you have to measure? Here we have to measure the net charge. What is the net charge? So what they are given outward flux of value of phi they are given. So we have to measure the charge value. So we have to measure flux phi according to phi it is equals to q upon epsilon 0. So we have to require flux is given, epsilon it is constant value. So we have to find out this one. So we have to multiply both this one, we are getting that the our value of q. So q it is equals to what, epsilon phi into epsilon 0, value of phi it is equals to what, 8.0 into 10 to the power of 3 Newton meter square upon coulomb. So what we are written 8 into 10 to the power of 3 into multiply of value of epsilon 0 it is equals to 8 into 8 5 into 10 to the power of minus 12. So coulomb q it is equals to what, 7.08 into 10 to the power of minus 8 coulomb. So this is a charge, total charge on our total charge, this is a total charge of this value or how much charge is that. So surface black box indicate that the net outward net charge inside the box is how much q, it is equals to 7.08 into 10 to the power of minus 8 coulomb. So now next question is that what is the question in the this question. Suppose we are talking about that the total flux is 0, outward flux is 0. Okay, surface box were 0, outward flux is 0. It means what, here flux phi surface of the box is where 0, so phi it is equals to 0. So epsilon 0 it is a constant value, so it will be not able to going to 0. So which term will be 0? Our q0 will be 0. So inside of the box there is a no charge, because of that there is a no flux. So given box might contain the equal amount of unlike charge whose net charge is 0. So when the q does it is equals to 0, it is not necessary that it does not contain any charges. Okay, so inside of that it is not contain any charges. Afterwards we are talking about our next term, a point charge 10q is distance from distance 5 centimeter directly of the center of cube. So see here there is a, it is they are drawn here like that. Okay, so this one, so we have to measure, this is 5 centimeters, so here it is will be placed at here from these positions to these positions. So what will be there? So we think of square one face of cube with the edge of 10 centimeter. So we can talk it is like that, so our square it is that. So see, so the statement of equivalent following situations. So what will happen, there is a 10 centimeter cube over there. So charge q it is where it is equals to 10 microcoulomb. Okay, so can be considered as the centroid cube side length is 10 centimeter. But see, there is a how much phases are there? 6 phase. Okay, in the cube there is a 6 phase are there. So we have to talk about the flux divided by 6 phase. But flux phi is equals to what? Q upon epsilon 0. So we know value of q it is equals to 10 into 10 to the power of minus 6 coulomb. Okay, 10 into 10 plus 10 microcoulomb. Okay, or 10 into 10 to the power of minus 6 coulomb. And epsilon 0 value we know, the phi of t, phi is equals to 1 by 6 phi of t, phi of t, and emanating from charge q is separated equally by the 6 feet. So see, that is a divide by 6. So q upon epsilon 0 it is equals to what? 10 into 10 to the power of minus 6 divided by 6 into 10 to the power 6 into 8.5 into 10 to the power of minus 12 is that. So flux, final flux phi is equals to 1.883 into 10 to the power of 5 newton meter square upon coulomb. 5 newton meter square upon coulomb. Now see, next question is that our point charge is 0 microcoulomb is that center of cubic Gaussian surface. So Gaussian surface, it means closed surface, so flux phi is equals to q upon epsilon 0, and surface 9 centimeter of edge is that. So they are given of value of edges, but it is for your confusion, the value of our surface we are not using. So what is the net electric flux through the surface? Any of the value of surface, it is not depend on any of the area, only flux it is depend on phi, it is equals to q upon epsilon 0. So value of q, it is equals to what? 2 into 10 to the power of minus 6 divided by epsilon 0, it is equals to 8 into 8, 5 into 10 to the power of minus 12 is that. So there is, so see, our flux phi is equals to 2 into 10, 2.6 into 10 to the power of 5 Newton meter square upon Coulomb square. So there is a no change in the flux due to the dimension of cube and positions of charge inside of the cube. Now next one is that, so a point of flux, point charge cause of electric flux is that how much? 1.0 into 10 to the power of 3 Newton meter square upon Coulomb to pass through the spherical Gaussian surface to 10 centimeter radius center of the charge. So if the radius of the Gaussian surface were double, how much flux would pass through the surface? So see here, even after making radius of Gaussian surface double, amount of electric flux passing through it, it will not change because the net charge enclosed by it remains same. So it means what? Here we are just considering as the charge, it is remains same. Okay, charge it is remains so. So there is a no flux will be double because flux phi will be depends only on this formula. So formula flux phi is equals to what? Phi is equals to q upon epsilon 0. So whenever we are talking about the q upon epsilon 0, on the time it is not related to any radius of the Gaussian surface. Then after, our next question is that point charge cause in electric flux of 1.0 into 10 to the power of 3 Newton meter square pass through the spherical Gaussian surface of 10 centimeter radius center on the charge. What is the value of point charge? So see here, we have to measure the value of point charge. So we can talk the according to Gauss law, phi is equals to q upon epsilon 0. So here what we have to measure? Here we have to measurement of the value of our q, value of q. Okay, so value of q we have to measure. So epsilon 0 into phi, we can see, we can get that the value of our q, charge value q it is equals to what? Here we are multiplying with the 8.585 into 10 to the power of minus 12 into 1 minus 1 into 10 to the power of minus 3. So charge q it is equals to what? Minus 8 into 8.5 into 10 to the power of minus 9 coulomb. Okay, again now we are discussing about our next question. A conducting sphere of radius is 10 centimeter has unknown charge. If electric field is 20 centimeter from the center of the sphere is 1.5. So see, electric field 20 centimeter from the center of sphere is that Newton 1.5 into 10 to the power of 3 Newton coulomb. So this one, it is our electric field, and point radially inward. What is the net charge on the sphere? So here we have to measure the value of net charge. So they are given of radius, the sphere radius, it is equals to 10 centimeter, the electric field 20 centimeter from the center, conducting radius of 10 centimeter are shown on charge. So see here, our r it is greater than r. Okay, so what will happen? The point outside charge there as sphere of radius r is that electric field point outside the charge of sphere. So suppose here we are talking about that the, we are talking about, see, this one our suppose sphere and outside of the surface. So we are in last lecture we are already discussed what will happen when r is greater than r. Then our value of q is equals to q is epsilon 0 k upon epsilon 0 into r square divided by k. So or e it is equals to k q upon r square. So here what will be there? Here minus 1.5 into 10 to the power of 3 into 0.2 into 10 to the power 0.2 into 0.2 square is that. Okay, divided by 9 into 10 to the power of 9, because value of it is equals to what? 1.5 into 10 to the power of 3 minus 1.5 into 10 to the power of 3, and value of r it is equals to 0.2 square is that. So we are written as 9 into 10 to the power of 9. So q it is equals to what? Minus 6.67 into 10 to the power of minus 9 coulomb. Okay, so see what will happen here. E0 is point is radially inward, and so it taken as negative. Okay, So here we are getting as here E0 point is electric field point is radial inward because R is less than R, capital R. Okay, so what we are saying that charge it is inside of the sphere. Now afterwards uniformly charge, our next question, sphere it have sphere of dia, it is 2.4 into 2.4 meter as surface charge density. So surface charge density it means sigma, it is value of 80 microcoulomb upon meter square. Find the charge on sphere. So we know about that the charge q it is sigma it is equals to q upon a. What is the q it is my charge sigma it is equals to sigma it is equals to what, q by a. So q it is equals to what charge is that, so q it is equals to but your area, the charge density depends on also area. So we have one value of q but we have value of our area. So what we can find, sigma it is equals to q by a. So it is equals to 4 pi r square. So value of 4 pi r square into sigma it will be gives the value of our q. So 4 it is that, pi it is value of pi it is equals to 3.14, value of r square it is equals to 1.2 into 10, 1.2 square into sigma it is equals to what, 80 into 10 to the power of minus 6 coulomb. So we are getting that the finally value of q is equals to 1.447 into 10 to the power of 3 minus 3 coulomb. Okay, so write down these examples. Now next one example is that a uniformly charged conducting sphere of 2.5 2.4 diameter has surface charge densities 80 microcoulomb. What is the total electric flux having the surface of the sphere? But see what we know about the flux phi is equals to q upon epsilon 0. So here q is equals to what, q is equals to our value of q it is we are finding in the last slide it is 1.47, see 1.447 1.447, see 1.447 into 10 to the power of minus 3 coulomb. So here you have to multiply with that only. So we are getting the divide by this value epsilon 0. So we are getting the net outward flux it is equals to what, 1.447 into 10 to the power of minus 3 divide by 8.85 into 10 to the power of minus 12 is that. So flux phi it is equals to 1.635 into 10 to the power of 8 Newton meter square upon coulomb. Okay, so this one it is that. Now our next question, an infinite line charge produce a field of 9 into 10 to the power of, so infinite line charge produce field. So here electric field is that, so electric field value it is what, 9 into 10 to the power of 4 Newton coulomb at distance of 2 centimeters. So distance r it is equals to what, 2 centimeter. Calculate the line charge density. So line charge density is equals to what, it is equals to k lambda upon r. Okay, whenever we are talking about the infinitesimal large road, on that time we are talking about this kind of situations. So electric field, this is the our this electric field formula, E it is equals to 2k lambda by r. So lambda it is equals to what, e r divided by 2k. So electric field into r it is equals to our radius, so we have to convert it in meter. So 0.02 meter divided by 2 into k which is that what, 9 into 10 to the power of 9. So we are getting that the final answer of our lambda it will be 10 into 10 into 10 to the power of minus 7 coulomb upon meter. Okay, 10 to the power of minus 7 coulomb upon meter. Then after we are talking about that our last question. So maybe it is our last question. Okay, no it is not last question. So see here what will happen, there is again the large thin metal plate are parallel and close to each other on their line surface. So this example we are talking in next lecture. Okay, still we are just consider this one only there is, see here what will happen, there is a no, here on the inner face and plate have surface charge density opposite sign and magnitude is what 1.17.0 into 10 to the power of 22 coulomb meter square. What is the E between this plate? So see here what will happen, the resultant electric field between the plate, here electric field both are E1 and E2 both are parallel. So here electric field it is equals to what, it is equals to sigma upon 2 epsilon 0, and also there is a sigma upon 2 epsilon 0. So both are sigma upon 2 epsilon 0. See sigma upon 2 epsilon 0 means, see this one is one of this one half, this one half, so half of will be become as 1. So sigma upon epsilon 0 is that, so 17 into 10 to the power of minus 22 divided by 8 into 8.5 into 10 to the power of minus 12 is that. So value of epsilon 0 we are divided, so we are getting that the E is equals to electric field, it is equals to 1.9 to 10 to the power of minus 10 Newton Coulomb. Okay, 10 minus 10 Newton upon Coulomb. So this one it is our today's topic. So afterwards our some of the example is remain. So guys, here our question is over all this exercise. So I hope you understand this all exercise, and also our another exercise is that it is an additional exercise. So you don't worry about this additional exercise, but those are student are doing preparation about JEE and NEET, they have to follow the our additional exercise. Okay, but still you have to write down in your notebook these examples and you send me on Google Classroom. Okay guys, if any doubt, if any problem, then you guys comment in the comment box. Thank you guys, thank you so much.